Okay, now let's talk about average atomic mass. That means we need to define what an atomic mass unit is. We define the mass of carbon-12 as exactly 12 atomic mass units. Then we can say an atomic mass unit is 1/12 of the mass of a carbon-12 by definition. It gives us a scale for weighing these atoms. The mass of 1 gram in atomic mass units is 6.022 times 10 to the 23rd. From high school chemistry, you should recognize that as Avogadro's number, and it turns out to be a convenient relationship as we move forward. We'll talk about that a little bit more later. In this case, we're going to talk AMUs of a single atom on average for a particular substance or element in this case. The mass you see on the periodic chart, as we mentioned previously, is the weighted average masses of all the stable isotopes. These have to be naturally occurring isotopes. We're not talking about man-made or lab-made isotopes. The bottom number in each element's box is the average atomic mass. That shouldn't be confused with the mass of any particular isotope, because that won't necessarily equal the average. There are some radioactive elements that don't have a stable isotope that have a number in parentheses. That number in parentheses is the mass of the most stable isotope, and so it doesn't represent an average in those cases. But let's take an example of chlorine. Chlorine exists in 2 isotopes, 75.77% chlorine 35, mass of 34.97 AMUs, and the other isotope 24.23% chlorine 37, which has a mass of 36.97 AMUs. Calculate the atomic weight to 2 decimal places. If you want a spoiler, it's going to turn out to be the mass of chlorine on the periodic chart, or better, or we don't have good data. So we're going to turn around and do that particular calculation and show that that is the case. So let's look at this weighted atomic weight problem. I've copied the data over from the problem text, and it works out a little better if you convert these percentages to a decimal. So I'm going to say 0.7577 and 0.2423. Now we're going to calculate a weighted average of each isotope. And so we're just going to take that percentage, which we converted to a decimal, and multiply it by the mass of that particular isotope. And then we're going to add the percentage converted to a decimal for the other isotope and the mass of the other isotope. Now, just imagine what we do get is the mass on the periodic chart, which is 35.45 atomic mass units. That's our answer, and it's the mass on the periodic chart if you look, and so we know we got the correct answer. On a test, I may give you a hypothetical element that's not a real element, so you have no way of knowing what the answer is before you do the calculation, so just be advised on that one.